This is section 6.3, part C, mean and standard deviation of a binomial distribution. What does the probability distribution of a binomial random variable look like? The table below shows the possible values of a corresponding probability for x equals the number of children with type O blood. This is a binomial random variable with n equals 5, so the number of children is 5, and the probability of success for each child is 25%. So the probability that exactly 5 of them will have type O blood is 0.00098. The probability that exactly 3 of them will have type O blood is 0.08789, and so on and so forth. Below is a histogram of the probability distribution. So the shape, the probability distribution of x is skewed to the right, since the chance that any one of the couple's children inherits type O blood is 0.25. It's quite likely that 0, 1, or 2 of the children will have type O blood. Larger values of x are less likely. To find the center, the median number of children with type O blood is 1 because that's where the 50th percentile will be located. To be able to find the mean of that, this is the same thing we were going to do that we've done previously. You take the x value, you times it by the probability, and then you add it to the next one. So our x value of 0 had a probability of 0.23730, plus our x value of 1 had a probability of 0.39551, plus, and you keep going all the way to 5. So on average, we would expect 1.25 of the children to have type O blood. To find the spread, you would first find the variance. And this is the same process we did earlier. So you're going to do your x value minus the mean squared, and then multiply it by the probability. So for our 0, for when x is 0, we're going to do 0 minus the mean squared times the probability of 0. Plus, you would do 1 minus the mean squared times the probability for 1. And you would keep doing that all the way to 5. And that would give you the variance of 0.9375. Remember, from the variance, to find the standard deviation, you just take the square root. So our standard deviation would be 0.968. So if the count x has a binomial distribution with the number of trials n and the probability of success being p, the mean and standard deviation can be found by just doing the mean of x is equal to n times p, and the standard deviation can be simplified to just doing the square root of n times p times 1 minus p. Or if we think about that last problem, our number of trials was 5, our probability of success was 0.25, which will give us 1.25. Our probability of success was our number of trials first is 5. So we had 5 trials. The probability of success was 25%. The probability of failure is 75%. And that will give us a standard deviation of 0.968. Remember that these formulas work only for binomial distributions. They cannot be used for any other type of distribution. So Mr. Bullard's AP Statistics class did the activity that was done previously. There were 21 students in the class. If we assume that the students in his class cannot tell the difference between tap water and bottled water, then each one is basically guessing. They have a 1 in 3 chance of guessing correctly. So let x equal the number of students who correctly identify the cup that contains the different type of water. Explain why x is a binomial random variable. Remember to check to see if it's binomial random variable, you are going to check the bins. B is that it is binary. So a success would be able to pick the bottled water. A failure is not picking the bottled water. I is independent. Each student's results are not influenced by any other student's results, so they are independent. N is a set number of trials. Since we know there are 21 students in the class who are participating, the number of trials will be 21. And the success rate, each child will receive 3 different cups of water, and out of those 3, only one of them will have bottled water. So the probability of success for each trial or for each student will just be 1 out of 3. Since x is counting the number of successes in this binomial setting, this is going to be a binomial random variable. Now find the mean and standard deviation. Interpret the values in context. Our new formula tells us that the mean is just going to be n times p. So the number of trials times the probability of success, which will give us 7. So we would expect that about 1/3 of the 21 students will guess correctly, or about 7 of those students will guess correctly. To find the standard deviation, our formula is n times the probability of success times the probability of failure. So we're going to take the square root of 21 times 1/3 and 2/3. So if the probability of success is 1/3, the probability of failure is 2/3, and that'll give us a value of 2.16. So if this activity were repeated many times with groups that included 21 students each who were just guessing, the number of correct identifying students would differ from the average of 7 by about 2.16. Of the 21 students in the class, 13 made correct identifications. Are you convinced that Mr. Ballard's students can tell bottled water from tap water? Justify your answer. So we want to find the probability the students guessed, 13 or more of them guessed correctly. So this class results correspond to x equals 13, a value that's nearly 3 standard deviations above the mean. How likely is it 13 or more of Mr. Ballard's students would guess correctly? So we're finding the probability that x is greater than or equal to 13. Another way to find that is just to do the 1 minus the probability that it's less than or equal to 12. Now we know that the number of trials is 21, the probability of success is 1/3, and the number of times that they are successful, if we're looking at just x is less than or equal to 12, would be 12. So you can do that on your calculator, or remember you can do that by hand. So we are doing 21 students. We're choosing 12 of them to get it correct. The probability of success is 1/3, and that would be 12 of them. The probability of failure is 2/3. If there's 21 students and 12 of them get it correct, then 9 of them would get it incorrect, and that would give you a probability of 0.9932. Or remember, you can do that on your calculator by hitting second vars, selecting binomial CDF, because we're doing less than or equal to 12. Your number of trials would be 21, your probability of success would be 1/3, and the number of successes would be 12, and you would still get that 0.9931. So to find the probability that x is greater than or equal to 13, you would just do 1 minus the probability that it's less than or equal to 12, and you're going to get a success rate of 13 or more. The probability of that would be 0.0068. So there is less than a 1% chance of getting so many right if they are only guessing. So this is strong evidence that some of the students in the class can actually tell the difference between bottled water and tap water. Let's check our understanding. To introduce her class to binomial distributions, the teacher gave her class 10-question multiple choice quiz. The options for the answers were A through E, and the teacher let a computer's random number generator produce the answer key. So it is possible for each question to be equally likely to be chosen for the different answers. Patty is one of the students in the class. Let x equal the number of Patty's correct guesses. We know that the number of trials is 10 because there's 10 questions on the quiz, and the probability of success, since the answers are labeled A through E, there are 5 answers. So each answer has a 20% chance of being selected. So we need to find the mean number we would expect her to get correct. Our formula for that is the number of trials times the probability of success, or 10 times 0.2, which means on average, we would expect students to get 2 questions correct on this quiz. Find the standard deviation and interpret this value in context. So to find the standard deviation, remember our formula is square root of the number of trials times the probability of success times the probability of failure. There are 10 questions. The probability of success is 20%. So if you have a 20% chance of getting it correct, you have an 80% chance of getting it incorrect. And so this will give us 1.265. So this means we would expect individual student scores to vary from the mean of 2 correct answers by an average of 1.265 correct answers. What is the probability that the number of Patty's correct guesses is more than 2 standard deviations above the mean? So let's first find 2 standard deviations above the mean. So if we do 2 times that 1.265, we're going to get 2.53. So we want to know that it's more than that value. So if we take the mean and we add 2 standard deviations above it, that's going to be 4.53. Now you can't get 4.53 questions correct, so it would have to be 5 and more. Or we can look at it if we're looking at x is greater than 4.53. That's the same thing as saying 1 minus the probability that x is less than or equal to 4. Now you can do this by hand, or you can use the option on your calculator to do the binomial CDF. If we're looking for the binomial CDF when x is less than or equal to 4, we know there are 10 trials. Each trial has a 20% probability of being a success, and we are choosing that 4 of the times they were successful, which gives us almost a 97% chance that it's less than or equal to 4. If you want to find greater than that 4 or greater than 4.53, we would just do 1 minus the probability that x is less than or equal to 4. So 1 minus that 0.9672, which gives us about a 3% chance or a 3.2 to 8% chance that the student gets more than 2 standard deviations above